Welcome to the DIY Honda Garage channel. The diagnostic trouble code, DTC P0533, indicates an issue with the AC pressure sensor circuit in the Honda Civic 2022 and newer models. This code is triggered when the output voltage sent by the AC pressure sensor exceeds a predetermined threshold, leading the powertrain control module, PCM, to identify an abnormality in the system. The AC pressure sensor is crucial because it monitors the refrigerant pressure within the air conditioning system, enabling it to function efficiently. Typically, this sensor is located near the AC compressor, which is responsible for compressing the refrigerant and circulating it through the system. The PCM is the computer that manages engine functions and ensures that the vehicle operates optimally. When a fault occurs, the PCM saves this specific DTC, alerting technicians to a potential issue that requires further examination and repair. The error code P0533 signifies a malfunction related to the AC pressure sensor, a critical component in regulating the air conditioning system. The primary role of the AC pressure sensor is to monitor the refrigerant pressure levels and relay this information to the PCM. If the sensor output voltage exceeds 4.75 volts, it indicates a problem, prompting the PCM to trigger the DTC. The pressure sensor is generally located along the refrigerant line, close to the AC compressor, ensuring it accurately detects pressure fluctuations. Its function is vital for maintaining the efficiency of the AC system and preventing damage from high pressure. If the pressure readings are incorrect, it may lead to malfunctioning air conditioning, affecting passenger comfort and overall vehicle operation. The potential causes for the DTC P0533 can vary, but they generally revolve around three main issues. First, a fault in the AC pressure sensor itself may occur, leading to an incorrect voltage output. This component may suffer from wear or electrical failure, impairing its ability to provide accurate readings. Second, the circuit connecting the AC pressure sensor to the PCM may be compromised. This can happen due to an open circuit or short circuit in the wiring, disrupting the communication between components. Lastly, a malfunction in the PCM itself could also be responsible for this error code, as the PCM may improperly interpret signals from the AC pressure sensor. Each potential cause must be examined during the troubleshooting process to isolate the specific issue. Diagnostic trouble code P0533 can manifest in several noticeable symptoms that may affect the vehicle's air conditioning performance. One common symptom is an inoperative air conditioning system altogether, preventing the vehicle from adequately cooling the interior space. Drivers might also observe a high-pressure warning, either through a dashboard indicator or via diagnostic tools, indicating unsafe refrigerant levels. Additionally, there could be reduced cooling performance, where the AC might blow warm air even when set to the coldest temperature, indicating that the system cannot regulate temperature correctly. Understanding these symptoms is crucial for diagnosing the issue, as they may lead drivers to seek repairs promptly to ensure comfort during hot weather conditions. The first troubleshooting step for diagnosing DTC P0533 involves initiating a series of actions in the vehicle. Begin by turning the vehicle to the on mode without starting the engine. It's essential to then activate the blower switch, followed by the AC switch to set up the environment for testing. The Honda Diagnostic System, HDS, should be utilized to monitor the AC pressure sensor voltage reading. If the displayed value exceeds 4.75 volts, this confirms the issue, effectively duplicating the failure condition indicated by the DTC. This initial step sets the foundation for further investigation into the AC pressure sensor's functionality and its related components, allowing technicians to proceed with methodical inspection. Following the initial confirmation of the fault, the next troubleshooting step focuses on inspecting the AC pressure sensor and the external circuit. Begin by visually inspecting the AC pressure sensor for any signs of physical damage or wear, ensuring that the wiring harness is properly connected and secure. Next, a detailed check of the external circuit is conducted, verifying for potential open or short circuits that may disrupt the sensor's operation. Special attention must be paid to the terminals and connectors to ensure they are clean and free from corrosion. The open wire inspection process is also crucial as it helps reveal any breaks or faults in the wiring that could affect sensor performance. By methodically addressing these components, technicians can identify whether the problem resides within the sensor itself or results from wiring issues. In the third troubleshooting step, emphasis is placed on directly assessing the AC pressure sensor's function by manipulating its electrical connection. Start by disconnecting the AC pressure sensor's 3P connector to isolate it from the system. Using a jumper wire, connect terminals number 1 and number 2 of the disconnected connector. This action will effectively mimic the sensor's operation, and then the vehicle should again be set to on mode. It's imperative to monitor the HDS for the AC pressure sensor voltage reading under these conditions. If the voltage remains below 4.75 volts, it indicates the sensor itself is faulty, necessitating its replacement. Conversely, if the reading exceeds the limit, there may exist issues upstream in the circuit or the PCM. The fourth troubleshooting step shifts focus to the powertrain control module, PCM, if previous inspections suggest normal sensor operation. Start by preparing to inspect the PCM, which may involve disconnecting its connectors to access the internal wiring. Ensure that both the A and E connectors of the PCM are disconnected before conducting any tests. Once disconnected, perform wire inspections for the AC pressure sensor circuit, particularly focusing on the resistance measured across circuit lines. This involves verifying that both PD sensor and SG6 open wires are intact with less than 1 ohm of resistance. If significant resistance is detected in any part of the wiring, this points to a circuit problem that needs addressing. Correct diagnostics in this stage are crucial, as identifying whether the PCM or the circuits are faulty can determine the next steps in repairs. Upon completing all necessary repairs for the DTC P0533, it is essential to verify that the system operates correctly before concluding the service. Initiate the process by clearing the DTC from the vehicle's system using the HDS. After clearing the code, it's crucial to retest the AC system to confirm that it is functioning without any further abnormalities. This involves checking for normal cooling performance and ensuring that the AC pressure sensor provides accurate readings below the threshold of 4.75 volts. This verification step not only ensures that the current issue has been resolved, but also confirms that no new issues have arisen during the repair process. A comprehensive retest will provide confidence in the long-term functionality of the AC system. Preventive maintenance is crucial to avoid the recurrence of issues related to the DTC P0533 and to ensure optimal performance of the AC system. Regular checks of the AC system can help identify potential problems before they escalate into major failures. This includes periodic inspections of the AC pressure sensor and its connections to ensure they remain secure and free from corrosion. Additionally, it's wise to inspect the wiring for any signs of wear or damage, as these can lead to circuit failures. Addressing worn components proactively will not only extend the life of the AC system, but also enhance passenger comfort. Adopting a proactive maintenance schedule allows vehicle owners to avoid unexpected repair costs and maintain reliable vehicle performance. In conclusion, the DTC P0533 is a significant error code that highlights issues within the AC pressure sensor circuit of the Honda Civic 2022 and newer models. This code primarily indicates high voltage output from the AC pressure sensor, leading to complications in the air conditioning system's performance. Key components involved include the AC pressure sensor, which monitors refrigerant pressure, and the PCM, which interprets this data for vehicle operation. Thorough troubleshooting steps include inspection of the sensor, the related wiring, and ultimately the PCM. Regular maintenance practices are vital in preventing this DTC from reoccurring, while ensuring the air conditioning system performs reliably. Understanding these factors can provide vehicle owners with the knowledge to maintain their systems properly and seek timely repairs when necessary. Please like and subscribe to the channel. See you next time.